What is test coverage? How do we test systematically using some kind of method that is repeatable and objective? How do we create an evenly distributed set of tests so that we cover everything in a sensible and an even manner? How do we measure our testing? How do we manage progress? And how much testing is enough anyway? Coverage helps us to understand several things. For example, what are we planning to test and how? It helps us to identify things to test and how we're going to cover them. Coverage tells us what we've covered when we've run those tests and what we've not covered, what's left to test, if you like. Coverage helps us to establish confidence with our stakeholders, and some confidence is gained by achieving 100% coverage of a model of testing, if you like. Coverage helps us to understand how thorough our testing is. And coverage has something to say about how good or effective our testing is too. But this is a complex question. We'll talk about that later. Let's start from kind of basics and look at a system. This is an oval, which represents our system, and the black dots represent the bugs that lurk in our systems. Now, we don't know where those bugs are, of course. If we knew where the bugs were, we could just fix them and go home. But testing helps us to identify the location of bugs through simulating transactions on the system, and when we expose a failure of the system that fails in some way, we can ask the developers to investigate, diagnose, debug, fix those failures. Now, there are some macro level things we can say about the characteristics of bugs in software. They're kind of sociable, and by that I mean they tend to cluster. We tend to see areas of the system that are relatively bug-free. Perhaps that area of the system is a very well established and trusted component that we've used many times before. But some areas of the system are going to be new. They may be complex, or they may be just prone to error. They're difficult to understand, perhaps. So we tend to see an uneven distribution of bugs in software. Now, the other thing we can say about bugs is bug fixing and maintenance of software is an error-prone activity. We know this because experience tells us that when we change something that works, we often introduce knock-on effects which are undesirable. So I want to consider using an analogy where we say testing is like a fishing net, let's say. We're going to go fishing for bugs, let's put it that way. So the size of the net reflects the size of the test, and the density of the mesh in the net reflects the depth or thoroughness or scale of testing, because a very dense set of test transactions, which is what the lines in the net represent. A very dense set of transactions mean that we have to create many tests. So large nets, large mesh give some overall confidence, let's say, but in certain areas of the system which are error-prone and complex, we use a smaller net, a finer mesh to find the bugs. So I've said, areas of the system that are critical are important to us, areas of the system that are complex and therefore difficult to understand and possibly error-prone. These are areas we're going to look more deeply into. And then there are areas that are error-prone. And error-prone areas are where we expect to find more bugs. Very often complex and error-prone areas are very similar. But let's take a broad brush look at how we might test from a business perspective. We would tend to do end-to-end tests of our system to satisfy the needs of our business users, our business stakeholders. And if you like, each line in the net represents a sequence of actions that take place across the system. So of course we're going to create a network of tests that span whole areas of the system in a very generic way. We're going to look at how the users use the system and use that to derive tests. So our test model perhaps is the business process that the users will use when they adopt the new system, or it could be user journeys, transactions that users repeat again and again, and we'll focus probably on the most important ones and complete our coverage, if you like, based on this knowledge of the business and how the users use the system. So we'll have this kind of very broad brush approach to testing the system as a whole. But what we know is that some areas of the system are going to be more complex and critical, okay, and more error prone. And by error prone, what I mean is they have a likelihood to fail because they are difficult to understand, perhaps they're not well documented, perhaps the developers are using technologies they haven't used before, or it's a new business domain that no one has experience of, and so the requirements might not be as good as we require. So some areas of the system, indicated by the finer mesh areas, if you like, in this picture, we were going to test a little bit more thoroughly, and we'll use perhaps different models in order to select a set of tests, and we may have a different stakeholder. So some of these areas might be architecturally critical and therefore more likely to fail. But there are also the more complex parts of the system. And the more complex parts of the system, again, probably error prone, but the technologists know that certain areas of the system are critical to the successful behaviour of the system as a whole. And so developers will tend to test complex parts of the software more thoroughly, simply because there's more that can go wrong, because there's more different behaviour that we can explore when we conduct tests in these areas. So each net that we've got on this graphic represents a set of different tests based on a different test model. And the developer test models might refer to the structure of the code in the system. The business user models will tend to look at user journeys or the business process. Now, if we take that strategy of having different models depending on who's doing the testing and where in our system's life cycle, we know some bugs are going to get through. We can't usually aim to eliminate every bug that's conceivable in a system. What can we say about the bugs that we actually don't find, that slip through the nets? Well, the first thing to say is if they're not in the business critical parts of the system, well, we could almost speculate that the users might not care about those bugs. They're going to be low severity bugs. If the bugs are not in the complex or error prone parts of the system, we would expect them to be in the less used areas of the system, the less critical parts of the system. And we can say this because if we pay attention to the business critical parts of the system, to the complex parts of the system and the error prone, where we know or have some knowledge and experience of error proneness of parts of the system, if we test these thoroughly, we can have some confidence that bugs that get through our testing should be fewer and further between them. They should be kind of more obscure because they're less likely to be thought of by users or technologists and testers. Now, in the test models video, I talked about different ways of looking at modelling and using modelling to identify things to test, whether it's decisions in a business process or paths in code. We used models and modelling to identify things to test. We call them coverage items according to the model. So what we can do is we can set a target for covering, for example, every decision made in the user journeys that are in scope. So this gives us an insight as to what we're planning to test. It gives an understanding of how much testing we're going to do and how we're going to conduct it. When we embark on meeting some kind of coverage target, we can use our model to identify what we've covered and what we've not covered. So we can identify what tests are yet to be prepared, but also when we run tests, we can also talk about coverage in the same way. The tests that we have run achieve a certain level of coverage, and the tests that are not run can be identified by the list of tests that are not yet exercised in our testing. Now, I'm talking primarily here about planned testing, not necessarily scripted, but planned testing, where we may identify test cases, conditions in spreadsheets or a test management tool. But in your exploratory testing activity, in your mind and in your notepad that you might be using to record what you're doing, again, there's no reason why you shouldn't set a target and work towards that target in your exploratory testing too. But let's look at what coverage achieved actually means. What does this idea of coverage tell us? What confidence do we gain from achieving 100% coverage rather than 80%? How thorough is our testing? What can we say about the thoroughness? And maybe is there an aspect of how good is our testing, how effective our testing is based on a measure of coverage? Well, we have to be very careful here, because our models are a representation and a simplification of the system or business process or user journeys as a whole. And so a measure of coverage is an indirect measure of thoroughness, let's say. Is a more thorough coverage target better than a less thorough coverage target? Well, there are kind of patterns in the way we define coverage, and some coverage targets subsume other coverage targets, so they are certainly more thorough. Whether they are better is a subjective view that we might take. And so the critical thing in all our models is that they should be meaningful to our stakeholders, whether those models are for our business users or our developers or systems architects. Can we say a high coverage measure means our testing is good and more effective? Not really. It's an indirect measure of the thoroughness of our testing, but that's it. The thoroughness is always measured with respect to a model. Now, if that model is very meaningful to our users or to our technical architects or our developers, then a higher level of coverage will give them more confidence should all the tests created from that model pass. Now, that's kind of it. There's no deeper insight I can give you other than a thorough set of tests based on a model that's recognizable and meaningful to our stakeholders will give more confidence. But there's no absolute measure of the quality of our testing or the effectiveness of our testing that we can do just with a coverage target. Now, one last thing I want to mention is if we use models that are, let's say, graphical, and we can identify things on those graphical models to cover and thereby set a coverage target, I would say that those models are objective. That is, if we create a business process and we have a flowchart or swim lanes and we use paths through that model to pick up decision outcomes in the flowchart, for example, we can say that that model is objective on the basis of we can all recognise decision outcomes on a flowchart, and we can recognise paths that exercise those business outcomes. And when we've covered all those business outcomes, the decision outcomes rather, we can say we're done. And most testers will come up with a similar set of tests to cover the paths that will exercise all the decision outcomes in a graphical model, a flowchart. And so an objective model allows you to identify things to test. And in general, our models cover the business process, the technical architecture, or the code perhaps in a component reasonably well, but they are simplifications. But that's the best we can do. We can only use modelling to simplify a very complex problem. But I have to say that not all models are objective in that way. For example, suppose we make a list of modes of failure, that is, the risks of failure that are appropriate for the system under test. Now, we can always think of new ways that the system can fail, because systems can fail in an almost infinite number of ways. So our job is never done. we never have a definitive risk register, a register of modes of failure that is totally comprehensive and that will satisfy every stakeholder. So a risk register, that identifies the risks to the product itself, to the system itself of failing, is not objective in that we can always think of more tests because we can always think of more modes of failure, more risks. So we have to be careful about how we model situations and whether we are actually looking at something that is, if you like, objective and thereby has a limit, or something that doesn't have a natural limit. Now we'll look at these aspects of risk-based testing, goal-based testing, and other informal models, people often call these heuristics, separately.